welfare. So for that, we need to have a measure of welfare. Normally, that's a utility function, and that's it's what we estimate in the structural model. Two is to conduct another experiment that was not done in the field, right? To say, what would happen, and if you have ever people raising their hands, say, well, what happens if you double the transfer, or if you give the transfer to another group, or things like that? And at that point, the discussion becomes all just talk, because the model estimated has nothing to inform about those questions. Well, in a structural model, you can do that. Of course, there's no free lunch in economics. And because there is no free lunch, there has to be a cost of moving into a structure. And the cost is that you have to make a lot of assumptions in order to identify the model. There are two camps in economics. One that say, yeah, we prefer to do all these assumptions, get the gains that a structural model can provide us. And the other people say, no, I'm not willing to 40 identification assumptions. I prefer just to have one very nailed down and get to this simple parameter that may not answer many questions, but at least whatever it answers, it's better answer, right? And that's basically the two camps division. So in 2015, I published a paper, and it was not the first, but I think it's the one that has the ideal characteristics of how to combine structural models and well-identified identification strategies. I will say most of the time experiments, because I think that's obviously the best case. And so in this lecture, what I'm going to do is first present the 2015 paper, which is a paper using Moving to Opportunity, which I gather is a program you know because of the topics discussed in this workshop. But in any way, the talk's going to be self-contained. And then I will use that model, that presentation, which basically I adapted. I'm not going to present exactly the same model that you'll find in the published paper in the American Economic Review, because that other model is more complex and it will have taken me more time than I was given to present it. So I will present a much simpler version of that model, but the results are very, very similar. Indeed, the version I'm going to present was our first version of the paper. Then it got more complicated through the referee process. And second, I will rely on a recent survey I did with Juan Pantano, which is also co-author in the NBER paper. The paper is also writing with Alvin Murphy. I will use that paper in which we sort of revise the structural model literature, and we move into suggestions for the next steps in that literature, which are a generalization of our AR paper. Please, if you have questions, raise your hand, and I try to, if I catch that, try to answer. Good. We're going to be looking at, as I said, into opportunity experiments. These experiments were conducted in the 90s in several cities in the US. We will focus only on Boston. You'll see when I show you the model, there's no gain in pooling other cities. And there were a series of papers by Katz, Kling, and Liebman, for example, in the QJE 2001, where essentially they show very little results. I mean, my reading was that, yeah, they were finding something on cream for females or something on obesity, but they were sparse results. I will say that overall assessment is that the program did not have many impacts. There's a more recent paper by Rachchetti, Hendred, and Katz in the ER that looks at a much longer term impact. Of course, that's more difficult because over time there is attrition. So the beauty of the experiment gets somehow reduced. And you have to deal with these issues, but it's a nicely done paper, and they find some interesting effects, mostly for children below 13. So essentially, the children that moved that when they were below 13 are the ones that many years later show some better outcomes. Okay. But in our paper, we will stay with the fact that in the short run, there's no effect. So we will, when people choose where to look, there's not going to internalize these effects on human capital. We're only going to look at advantage or disadvantage of the neighborhood in terms of characteristics of the neighborhood. Okay, and that was justified because at the time we did the paper, this paper by Shetty did not exist, but even if it would have existed, these are so long-term effects that are hardly likely to affect or would have been known at the time of moving as to affect where to move. Right, we do reduce form, and that's what all these previous papers done. They estimate the intention to treat effect. So in this program, you know, people were living in governmental housing. Those were subsidized, and they were paying just a subsidized rent. And the idea is to move them from those that are considered places where negative externalities to places where the externalities could be at least not negative and hopefully positive. Okay, and that will mean moving out of those buildings where most people live on welfare and are stuck there into other neighborhoods where they mix with the general population. And that's where the less negative externalities or even positive externalities could arise, right? So these families receive a voucher randomly. I tell more about this for these slides. It's enough that we think that they have some random possibility to move, whether they use it or not is endogenous. So you can estimate the effect of having the voucher on outcomes, and that's going to be the intention to treat. But for us as economists, it's more interesting what's the effect of moving using voucher. So also people instrument moving with having the voucher as an, sorry, will instrument the dummy, whether a family move or not, with the instrument being having received the voucher randomly. And obviously, there's gonna that following the literature is gonna be say that identifies a local average treatment effect, which is the effects on the compliers, right? The compliers are the people that when they receive the voucher they move, and when they don't receive the voucher they don't move. But there are other people that could move without the voucher or with the voucher, and those, you know, are always takers, and vice versa will be never takers. So the instrumental variable identifies effects on the compliers. Is that there are heterogeneous treatment effects, and when there are heterogeneous treatment effects, it matters a lot who complies. So the interest in identifying effects for subpopulations that take advantage of different policies became very important. But to do that, we need to understand who complies with different housing assistance policies. And that's what an structural model can do, because once we have a model, how make in terms of a large vector of heterogeneity characteristics, and also in terms of an observables model in certain way, you can sort of predict who moves and who doesn't under the current experiment. But as I told you at the beginning of the lecture, also under other possible experiments that were not conducted. Okay. And that's the beauty of having a structural model, because you can do all these counterfactual scenarios without having to run a multi-arm experiment that is of course, you have to believe in the model for all these counterfactual experiments to have some value, and that's where we came and say, well, yeah, we need to validate the model. We are not the first, but we need to validate the model and to get more of those. To validate the way, that's where we make our contribution. So to summarize, the idea is to formulate and estimate a structural model of a neighborhood choice. Use the model to understand who will take up the voucher under alternative policies. Use part of the experimental variation in MTO to estimate the model, but also of the experimental variation in MTO to validate the model, right? So these are all important. So the fact that we use part of the experimental variability to estimate is important because it relaxes the number of assumptions in estimation. But the fact that we use part of the variability to which is experimental, to is what gives us credibility, and then we basically believe that the new experiments we conduct are of use, are of value in terms of identification. Okay, I just said I'm going to present you a simplified version of Galiani, Murphy, and Pantano in the year 2015. Yeah. Okay, so there is a previous literature. I think someone in the chat is asking something. Oh, okay, it's administrative. Sorry. So I think these papers are in one experimental data estimation. We have Takeup, Wolpin, and Hannah and Ryan, Takeup, Wolpin, and Galiani and Pantano. And these two, Takeup and Wolpin 2020 and Galiani and Pantano, are kind of surveys, although taking different avenues. I mean, surveys in terms of what's the path of the structural model are that different. I mean, we choose to highlight different stuff, but in terms of future avenues is where the main difference is. And that's what I'm going to talk in the last slides of this presentation. Let me check how I'm doing on time. Okay, then there is the papers on MTO, the reduced form literature there, and there is a paper that tries to identify a neighbor effect, but with a very, very strong assumption. And then, so I will mostly think about these papers here that estimate the intention to treat and treatment on the treated, that estimates discrete choice models of neighborhood choice, right? Urbanomics, the urban economics literature is the one here. So basically, we're going to take the standard model here and combine with MTO data to estimate a neighborhood choice model, but in the literature of a structural estimation that tries to validate the model. Okay, so that's what we're gonna do. In MTO was done in 5 sites. We use data on Boston. Having access to this data was very difficult. It changed a lot over time, so it was given to us with certain restrictions. We couldn't access to all the data that exists, and we have to have it in one computer in one office at the Washington University at the time, and we couldn't move the data, put it in another laptop or anything like that. So that added to the complexity and time needed to estimate these types of models, but also who hold the data change over time, and then at some point we have to give the data back, and so it's very restricted. So I was surprised by that, given that these experiments were many years ago done. Okay, the program is standard, right? Eligible public housing residents are invited to enroll. Conditional on enrollment, then there is an assignment to 3 groups. The control group, which gets nothing, is basically where they still are subsidized, but they don't get any new way to get the subsidy. So they can move, but then they are alone if they move. Section 8 treatment group, this is like the standard program. And basically they get an unrestricted subsidy, which are 2 types, a voucher or a certificate. In this short lecture, I'm not gonna talk a lot about the difference. I'm gonna only tell you about the voucher, right? But in the paper and in the estimation, there is the 2 types of instruments taken into account. And so the subsidy, the voucher, will be characterized by 2 parameters, sigma and rho, and I'm going to tell you later what they are. And then there is this experimental treatment group, which is something that they knew they were trying at the time, which basically introduced a restriction on the type of neighbor people can move using the voucher or certificate. And those were neighborhoods with poverty rates below 10%. And that's what will be this tau here. This tau will be the poverty rate. But the program also offers mobility counseling, and if mobility has a fixed cost to pay, we will assume in the model that this counseling can potentially reduce the cost of mobility. So this treatment is different from this treatment in 2 dimensions. One, that asks families to move to more expensive neighborhoods, and because of that, less families should be taking the possibility of moving, but also it's offering counseling, and the counseling, because of the counseling, more families should be taking. So comparing the reduced form of this group to this group will mask these 2 effects in contrary directions, and you cannot separate them with reduced form estimates. There's no way you can do it. However, with the model, we can do that. And I'm going to show you as a way for you to see the advantages of having a model to conducting counterfactual experiments. Okay, sigma is the share of household income to be paid out of pocket. So that's like the subsidy tax. For example, if sigma is 0.3, that means that the families will pay 0.3 of their income as a rent in this program, whether they are independently on whether they are living. Right? This rho is a cap, is maximum that these families can have when they move using the voucher or the certificate, and this when people is in Section A, the maximum poverty rate. Okay. Right. So normally if you think about using this in a reduced form way, we will have these two dummies, right? The G1 and G2, which indicate what type of treatment. I'm not making a distinction whether they get a voucher or a certificate, because that anyway, I'm gonna put everything in the budget constraint, and I'm gonna assume that other than that, the way they operate through a budget constraint, there's no difference. But in the reduced form, no one make any difference between a voucher and a certificate. Okay, so you will have these two groups plus the control group. So if we want to look at the take-up will be this dummy DI, and if we estimate the take-up as a function of this will be the first stage of the latte estimator of the two treatment dummies and a bunch of control variables, what we are going to have is that section 8 with controls or without controls is very similar, obviously, because this is random, right? And controls are orthogonal to the treatments. But we will have that those on section 8, those that did not have the constraint to go to poverty below 10 and didn't have counseling, took up the voucher in almost 60%, but those in the experimental group did it in 46%. So there is a much lower take-up when people have to move to more expensive neighborhoods. But then the question is, you could conclude that the difference between these two is because they have to move to a more expensive neighborhoods. And what I'm going to show you is not. Because the people have to move to more expensive neighborhoods, the difference is much larger. But then because they get counseling, the difference narrow back, and this is the reduced form, because the reduced form is a combination of the two effects. They don't separate. They cannot separate both channels. Okay. So model will be a standard model, as I say, in the literature of neighborhood choice. People will be maximizing utility, and what they have to choose is the neighborhood in which they will live, right? This D will indicate neighborhood I. And so the utility is gonna be a function of consumption. It's gonna be a function of the income of the family for not because of the budget constraint, but because essentially some parameters we assume will vary with the income, right? The heterogeneity in income. Characteristics of the neighborhood that are observable, characteristics of the neighborhood that are unobservable, characteristics of the family other than income that are observable, and then an indicator of where they moved, where they were living in the previous period. And you'll see why this is important. And then the standard shock to family neighborhood match, okay? And this will be the vector of parameters. Obviously, we can also model what not only the neighborhood, but what type of house people choose within neighborhood, and that's what you find in the published paper. But that's a complication analytically that doesn't add to the main exercise that we do in the paper, and because of lack of time, I decide to present on a very simplified version of the model. Okay, the budget constraint then gonna be that the income of the family is used for consumption and to pay the rent, and the rent is the rent of the family I living in neighborhood J, okay? So we can substitute consumption here by Y minus R, and we will get this, sorry, and then this rent that people depends on many things. Will depends on the market rent, right? So like if every family is looking at the same neighborhood, they should in principle pay the same. but because they are in different groups and they will be receiving subsidies, that's going to create a lot of variability in this rent out of pocket. And this variability, which is driven by the randomization, is exogenous, will be exploited by us in the estimation of the model. Good, I explained these parameters already. So the rent out of pocket pool or the crime rate or the pollution, you know, whatever you think it's important, have data for, and these parameters can be heterogeneous, right? It's going to be a function of the rent pay, and again, this parameter can be heterogeneous. And then this lambda ij will be the moving cost I was talking about. And this will be the unobserved characteristics of the neighborhood, and then the shock to the match family neighborhood, okay? So this is not observable, so normally it's just a dummy in the estimation. So then there is two ways to deal with this heterogeneity. One is that to assume that they follow a certain distribution. Is to suppose that a common parameter, let's say an intercept for each of these parameters, and then they are linear functions of the observable characteristics, and that's what we do. And now for the price effect, right? For the rental price effect, we will assume this should be negative, right? Beta 0 should be negative. People, the higher ceteris paribus, the higher the rent, the lower the utility, but we will assume that decrease with the level of income. So the higher the income, the less the rental price effect in terms of utility. Now, there was this moving cost, so people will be paying the moving cost when they live in a neighborhood, when J is different from J in the previous period. And that's why it appears in the utility function, this indicator, because once the family is evaluating a neighborhood, which implies a move, that makes up to pop out the moving cost. And the moving cost, we were going to model as just an intercept moving cost, some general moving cost, and a potential reduction in the moving cost lambda 1 that is produced by having counseling. Like the idea is that counseling reduces this moving cost. And this error term of the model, the shock, it's assumed to follow an IID type 1 extreme value, and that's what the literature does, because these produce a nice likelihood that can be easily maximized. Okay. Right, so we now plug in the alphas and beta. We get the very general formula for utility, and then plug beta 0 times the market rent, and we will get this utility. And what I want you to notice is the following, that, for example, if you are doing this type of estimation without MTO, and you don't have that different families will pay different prices for the same house or the same neighborhood, you don't have variability in Rij. So this will not be, will drop from here, because it's gonna be, there's not gonna be variability, right? So the only price that families will be facing will be just the market price, which is this one that has this M here. But this market price will be perfectly collinear to the unobserved characteristics of the neighborhood. So that's, this beta 0 will not be identified, right? And here, it will identify beta I, but only because it's an interaction term. But none of the intercepts will be identified when are the variable associated to them is collinear to the neighborhood fixed effect. So what people do is estimate this model without having this variability, and hence without estimating beta 0 here by maximum likelihood. And once they get this parameter here, these dummies for each neighborhood, they go and estimate that neighborhood effect against all the characteristics of the neighborhood. The problem to estimate this is that all these observable characteristics, right, having good schools or the price, are with an observable characteristic. So you need instruments for all of these variables. And where you're going to get instruments is very difficult, right? And that's the problem of the literature. Now, what we're going to show you, what I'm going to show you is that I have one advantage. And that advantage is because of I'm going to use one arm of the randomization that gives me variability in Rij. And because Rij is not collinear to delta J, I will be able to identify beta 0, right? And because I identify beta 0, then if I don't care about alpha 0 for any of my counterfactual experiments, then I don't need to come to this second stage, and I don't need all these instruments that I don't have. And that's beautiful, because that's exactly the case in my paper, really. I'm not interested I mean, sure, I could have exercise in which I could report something that depends on alpha 0, and we do one in the paper, but it was mostly to show it was not part of the important question. The important questions only are about who moves using voucher and where, right? That's what we care. How people choose where to move, and all that information is here. So I don't need to come here. I'm fine with conditioning on the fixed effects if my experiments are not related to changing the x, like the quality of the school. Obviously, if I wanted to say how people move differently when I improve schools in neighborhood 4, yeah, I need to know alpha 0, but that's not what I only care about. Things related to MTO, and hence I don't care about anything related to the characteristics of the neighborhoods in my counterfactual exercise, other than they interact, right? Only to the extent that they are part of the heterogeneity, but that is identified in the maximum by the maximum likelihood estimator. So I can estimate this model by maximum likelihood estimator and don't have to bother with all the instruments needed for identify the alphas, and beta is identified here. Now, the Bashe constraint, I need to fast a bit, right? I have, what, 10, 15 more minutes?
Yeah, around that, and we can take questions before.
Yeah. Okay, let's try to do it in 10 more minutes. Okay. So the Bashe constraint is this. So if the family doesn't move, they keep paying the same rent as before in the public housing. And that rent was sigma of their income. So when J is equal to JT minus 1, it doesn't matter in which of the three groups a family is, the rent is just the rent they were paying. Now, if now the family moved, that means J is different to JT minus 1. If the family was in the control group, well, now they are in their own. It's like they just give up on the subsidy because they're moving because they decide to move, but that implies leaving the subsidized housing, and so now they have to pay the market rent. if essentially they are in section A, so they got section A, and hence they have a voucher, because they could have a certificate, but because of time, I'm not going to talk about the slight difference between having a certificate and in the voucher, but they are all taken into account estimations through this budget constraint. What happened? Well, the family will pay, there is a cap, right? There is a cap rho. And so if the rent they pay is below the cap, they will keep paying as before, sigma times delta I. And if they go above the cap, if the market rent is above the cap, they will pay the difference between, in addition to sigma their income, they will have to pay the difference between the market and the cap. And now if a family is in the experimental group, have a voucher, but move to a neighborhood that has a poverty rate below the one that was indicated by the program, which is 10%, then it's like they lost the voucher and they have to pay the market rent. But if they move to a place where the poverty is below the 10%, then they can use the voucher, and the pricing rule is exactly as in the section A. Okay. It's very important, this budget constraint. I find it extremely, for an economist, telling about what aspects you will expect to find in terms, for example, living welfare. And I wasn't surprised that the program didn't find effects, given that the marginal tax on an extra dollar was so high. Okay, so we estimate the model, the parameters all looks fine. For example, the marginal utility from the percent wage in the neighborhood is positive. The marginal utility from the poverty rate is negative. And all these are just interactions showing heterogeneity. The moving cost is negative in terms of utils, but having counseling reduced the moving cost in about 20%. And then the price effects is negative, but it's less negative the higher the income of the family. See, all the coefficients goes with the right sign in the model. So now I'm gonna tell you, I estimate the model using the control group and the experimental group, because that model, I need to use the experimental group to estimate the moving cost, because the section A don't face the moving cost. And also it's the one that has the encompassing budget constraint, right? The one that has tau in the budget constraint. So what we did is we estimate the model then using the control group and using the experimental group, and that experimental variability give us the possibility of identifying beta zero, right? We have it's like we have a perfect instrument for identifying beta zero. And now we're gonna see if the model performs well on sample. On sample means on the data used for estimation. And so we will look at several moments. Moments will be unconditional on move using a subsidy, percentage who move using the subsidy, and conditional on moving, right, using the subsidy. So, for example, we see here the combine, the percentage move, the control group, and the experimental. And the first line coincide, that's of the estimation, but all of the others should not necessarily coincide, at least the model fits well. And here we have, for example, 27%, 28, 33, 34, 21, 22, 41, 43, 36, 37, 47, 48. So it fits extremely well. Here it doesn't fit that well. Obviously, this is 0 and 0 because people could not do that. 4739, that's one in which the difference is greater than 10%. It could be large or potentially large. And then 6%, 78%, very good. So overall, this is considered a very good fit, right? We just have a discrepancy on one moment. Now we are gonna take the model, apply to predict the same moments, the same variables for section A that was not used. So section A doesn't have counseling, so we go to the model and shut down counseling. It doesn't have the constraint of poverty. We shut down that, but after that, we use the estimating model to predict what they should have done if the model is what dictates what they do, okay? And now we validate the model outside the sample. We will validate into a treatment group that is not used in the estimation, right? So again, we predict very well: 61, 50, 58, 27, 28, 38, 40, 58, 58, 21, 19, 40, 50. Here we miss for more than 10% one, but it's different from the one we were missing before. So again, I think what this shows is that the model, the model does a really good job in predicting in sample and out sample. And so once you are here, and if you decide that you believe the model as a good characterization of how families choose to move when faced under this set of incentives, you can try to change the set of incentives and do counterfactual exercise. I'm gonna go in 1 minute to that very fast because I only have 2 minutes left, but I wanted to say something that I wanted to elaborate more, which is the arguments we make in the Pantano Galiani 21 survey of why this type of terms, one that is used for estimation and the other is used for validation, is the best strategy. Well, because the arms are randomly assigned, right? Well, because if they're not randomly assigned, you're never sure that the unobservables got balance in ways you separate the groups, right? And so when you find difference, it could be that the unobservables were, so that's great. But also, you could say, well, I don't do out of sample validation. I just take one group. So suppose I only have 2 arms. One group for estimation, the other group for both groups for estimation, and I only do on sample validation. Well, if you do that, the problem is that you don't expose the out to a more difficult test to pass, which is the out sample test, in which you are using the model that you estimated under people that face different constraints, but then on average were the same because they were randomized from the same population. And what you want is that when you change the constraints, the model still behave, because that's exactly what you're going to do in the next exercise, which is an experiment conducted. And that's the reason you want the structural model, to try new experiments. But for that, you want to know that it already worked, right? When you did that. You see what I'm saying? And that is the ample validation. That's why it's the best possible use of experiments with experiment is to have 3 arms, is use one for estimation and another for both for 2 for estimation and 1 for out of sample validation. Okay. So, for example, one thing I can do with the the issue of the take-up, remember that the take-up in section A was 58%. And now we estimate with the model that without selling, it would have been 26%. So essentially, forcing people to move to places below 10% have cost families a lot, and they will have taken substantially less, right? Like half of them will have taken only. But because counseling, it bumped up to 40%, which is close to what we before. When we show this paper, this result was a bit questioned, but I think now people should believe it more because there is a new paper by Bergman, Shetty, De Luca, Hendred, Katz, and Palmer in Seattle that confirms the importance of counseling in reducing barriers to mobility. So in that way, this paper follows on our finding for MTO. Okay, so you can do many other counterfactuals. I don't have time. I only want to talk about one because there was a big discussion among the people that have studied MTO and the critics argued that the problem was that the reason why the original papers, the first papers, the short-term papers were not finding effects was that impose the restriction on poverty, and it should have been on race. The race matters more than poverty. So instead of asking 10% poverty, they should have asked 17% race. And there was discussion, there were papers, but the truth is that it was speculative because no one had estimated the model. And what you need to answer that is to say, well, let's impose a constraint of 17% raise and see if people will have moved different. And the answer is no, they will not have moved differently in this table. They will have moved exactly the same. And the reason for that is because there's a very large correlation between the poverty rate and the percentage wide in a neighborhood. So it doesn't really make much of a change. And hence that's that discussion saying, yeah, the MTO people was right when they claimed that's not the issue. Okay, I'm not gonna go that into detail in the survey because I don't have time, but if you are interested, I invite you to read it. And the key slide is this one where I show how different possibilities of using treatments and different arms of treatment and control for both identification and validation, that's the best option, right? Okay, I think I'm done now.
All right, thank you so much, Professor Galiani. We can now take some questions. We have 10 minutes until the session ends, and then we can, if Professor Galiani is available, we can stay back a little bit after if there are any other questions. But if you do have a question, you can either raise your hand and ask it live or direct it to me in the chat. So I've gotten a couple over the course of the session.
Yeah.
So the first one is, since the MTO experiment is randomized, how did researchers determine that the low-income families who moved to private market housing in less distressed communities were successful in their new housing?
Sorry, I didn't follow the question. Can you repeat it?
Yeah, I can also send it in the chat also,
okay,
to make it easier. So again,
I can read it. Since the MTO experiment randomized, how did researchers determine that the low-income families who moved to private market housing is less distressed were successful in the new house? No, that's a question for the previous literature that look at stress, look at, as I say, crime, obesity, income, welfare. They look at those type of outcomes. The only thing we study is who moves and who doesn't. So with our model, we cannot say anything about this. I mean, we assume that people choose rationally, maximizing utility. But we, as I said at the beginning of the talk, we did so because in the previous papers there were not many effects on these outcomes. And so I cannot say more than that. But if you talk to the authors of the Liebman or Larry Katz, you can engage more with them because they look at those outcomes.
All right. Next question. I'll send it in the chat again.
In a frictional model, whether low-income families decide in low opportunity or high opportunity areas depends entirely on preference. Why do you think that the barriers between low-income families and high opportunity areas are imposed? Is enacting it? Well, we don't assume that there are no frictions, right? That's why there is transaction cost. There are frictions there, so we know that when these families go to, but first, for example, they need to know whether the neighborhood is a 10% poverty or above, so things that are not such easily available. So counseling was very useful for that. They also can get counseling on how to deal with, for example, for certain ethnic groups, there could be a barrier to deal with white landlords, and they get counseling on how to do that. So in that sense, I think we don't model everything that goes inside the counseling because we don't have data for that. But the frictions are in the model, right? We don't have a frictionless model.
All right, we can take the next question from the raised hand. So Pranav, you can ask.
Hi, yeah. So I know you talked about the take-up rate differences between people who were restricted or like were restricted to those more expensive neighborhoods or not. So would you say that it's more of like a psychological issue where people are less likely to go to these higher income neighborhoods because they don't feel they'll fit in? Or is it because you think it's an economic issue where these people think that it'll be more expensive for them long term if they move to these more expensive neighborhoods?
I mean, it doesn't matter what I think. I tell you what I can tell you, okay? Which I think is more productive always. What I can tell you is that in our model, we assume that was mainly an issue of difference in cost. It operates through the budget constraint. And we fit the data well. So I think income plays an important role. If you ask people to move to expensive places, they are less likely to be able to do it. But then on top of that, if there is some psychological issue, I don't know, we didn't have such things in our model. But we explain, but the point is we explain it, the data very well without that, right? So I tend to think that it's not important.
We can take...
I'm sorry, to follow up on that, I think because of the model assumption that the model assumes rationality, so psychological factors are not relevant to the model because of the assumption of rationality. Correct?
Right. The model assumes, assumes that families maximize utility, and that is a bit more even than rationality. Yeah.
All right, we can take.
I mean, of course, again, the moving cost in part could be psychological, right? I'm not neglecting that, but I don't have in the data set something psychological variables to explicitly model the moving cost. So for me, it's a black box, right? But you can interpret, but there is an interpretation. What's the moving cost? It's information, or is psychological barriers. It could be both. We don't have data to disentangle that, but that is in the model. It's what makes the model not frictionless, and it's the place in the model where you can think of psychological effects.
Thank you.
All right, we can take another chat question. I'll paste it in the chat.
Well, the whole idea was social integration, right? The idea was that by moving people from the public housing, where all inhabitants were on benefits, into neighborhoods where there was a different mix of people, that will generate realities and will generate positive results. But again, that's not what we study in the paper. We don't study whether those externalities existed and had positive effects. And as I say, in the first wave of papers that study that, the reduced form papers looking at outcomes, there were not much effects. It is only in this new paper by Larry Katz and Chetty and co-authors in 2020 that they find some long-term effects for the children that moved below 13, when they were below 13 years at the time. So I'm answering more this question based on the other papers, because our paper is only about, how people decide to move and where. And we use that to answer some questions, right? But that's not about the impact effects of the externalities on family. That's not what our paper is about.
Okay, we'll take one more question. John, you can ask your question live.
So for one of the groups, where they could move was restricted by a maximum amount of people who were below the poverty line. So how do you think that your model or results would have changed if instead of using like a maximum, they just used a percentage relative to the percentage where the person was moving from, or where the person was receiving the vouchers?
Well, that's a great question, because it's not what I think. What I think, it doesn't matter. I can calculate that with the model. I can sort of say, what if I will have put 2.5%, 5%, 7, 10, which is the one that they use, is 15 or 20, and look at the take-up, right, for example. And obviously, you see, the lower the poverty rate, the lower the take-up, because it's more and more expensive, right? To move to a neighborhood where there's only 2.5% poverty is much more expensive than to move to a 5% or 10. And so here we see different take-up. Different take-up per se doesn't mean different outcome, right? If what we care is what will be the mean poverty rate of those that move, yeah, obviously we will get lower poverty rates. The lower is the poverty rate that we take as a maximum. That's not surprising, because it's conditional in using the voucher. But if we take unconditional, we don't see difference. That's beauty, right? It says, well, for the whole group, if we want to maximize, if we want to get an outcome with minimum poverty rate for the whole group, what poverty rate we should put? 2.5%? No, we get even more poverty if we put this, because very few move, and so too many stay in high poverty areas. And so in here, it seems that the optimal for that is 20%, not 10%. But there's not much difference between 10 and 20% anyway. It's just 1 point of poverty difference. So I don't think that it was ill designed by looking at this. But this you can only answer because we have the model. Without the model, it will be just all speculative. You see, and that's the beauty of an structural model.